Now let's examine the graph. This function f of x equals, this is a piecewise function. It's in 3 pieces, right? The first piece, we said it is f of x is what? 2x plus 3 for x less than minus 3. And then the same function is x squared plus 3 for minus 3 less than or equal to x less than 2. And the same function is a constant 7 for s greater than or equal to 2. Now, let's see a beautiful thing. Now, one thing before we go to the graph is that, number one thing, let's talk about when does the limit of a piecewise function exist. And may I say this, if we want to examine the limit, we pick the end point, like the point that join 2 pieces. Like the point joining these 2 pieces is what? Minus 3. So if we want to examine the limit here, we can say limit as s tend to minus 3, or the point joining these 2, that's 2, or we'll say limit at x tend to 2. Now, when does limit of a function said to exist? Now, when we are done with the limit, then we'll now go to the concept of continuity. Are we here? Now, the limit of a continuous function is said to exist. Now, limit, let me say limit as s tend to a of f of x is said to exist. Of course, you know, the condition for limit of a function to exist at the point is when the limit from the right of the function is equal to the limit of the left for the same function. Limit from the right, or we call it right-hand limit, matches the left-hand limit. Now, somebody is now thinking, how do I know the left-hand limit of a function? Okay, let's assume for this function here, for this function f of x, somebody say examine the limit as s goes to what? S goes to minus 3. And then somebody is saying, how do I know that part? How do I take the limit from the left? Don't forget, let's show you a number line. Now think of this number line. Let's even come back here. I think of a number line. And then the point of interest here, our point of interest is minus 3. But we say limit as x approaches minus 3, not x equal to minus 3. There's difference from approaching something and what you are equal to. So as x is approaching minus 3, let's see how that will be. That's minus 3 is the point of interest. Now approaching from the left. Numbers that are approaching this, okay, somebody is first thinking of a minus 4. And then from the left, you are thinking of a minus 3.5. And then fast forward, you are thinking of a minus 3.1. And then, minus 3.1. To the left, you are still right. And then you're pushing, getting closer to this. That's from the left. So that is from the left, you can say from the left, based on piecewise function definition, it will be not the region where x is less than 3. Less than minus 3, That will be the region we use for the left. The region where x is less than minus 3. Now, okay, how about from the right? We are using the region because from the right, we are thinking of numbers that are greater. The right of this point, the right of this point, and numbers greater than minus 3. There you have minus 2. If they are integers, you have minus 1, you have 0, and you have it like that. So, but then, if you are examining limit, it will be within the same neighborhood. Somebody will not say, since they say it's point greater than, and then you go and use the third part of the definition. This is rather too far. It will be within some distance, in fact, some 0.1 distance to the left and to the right. So if I go 0.1 distance to this, I will definitely get what? That will be minus 3.1. That's if I take minus 3 minus 0.1, to the left, that's minus. To the right, plus. Minus 3 minus 0.1, that will be what? Minus 3.1. And if I'm going 0.1 to the right, that will be minus 3 plus 0.1. That is minus 2.9. Now, obviously, because we say this region here, minus 3.1 is within this region. So I'm using this definition for that part. And minus 2.9 is within this region because say minus 3 is less than or equal to. So minus 3 and 2 minus 2.9 is within this region. So if I want to examine the limit now, what will I do? Okay, the left-hand limit now. Look at me. I'll say the limit from the left. The limit from the left of f of x. I said we are going to pick what? We are picking this particular part. We are picking this part for the left. We are picking this part. So I will say that will be equal to what? Limit as s goes to 3. Minus 3, sorry. As s goes to minus 3 of what? I'm just picking the function that satisfies it. And then if you understand the property of limit very well, we tell you that limit of function oftentimes, if it exists, it's always the same as imputing it. That's why if we tell you to solve questions on limit, it's directly the same as what? Substituting. So I'm just going to substitute here. So this is going to be what? 2 into minus 3 plus 3. And this is what? 2 into minus 3. Someone is saying what? God bless you. This is what? Minus 6 plus 3. And there I think we get a minus 3. Now let's impute. Limit, let's check. This is limit from the left. You get minus 3. Don't get it wrong. Minus 3. Now let's see the limit from the right. Limit as s approaches minus 3. Oh, minus 3 from here. S approaches minus 3. S approaches minus 3 from the right of f of x. And that will be limit. We told you that from the right. When we gave you those 0 point something distance, we notice it's in this category. So I will use this part of the definition for it. Are you getting what I'm saying? So I will use limit as, I'll say that will be equal to as s goes to minus 3 of what? The definition x squared plus 3. Now x squared plus 3, you can put minus 3 into this. That is up like we said earlier. Minus 3 squared plus 3. And this is what? Minus 3 squared. That's minus 3 times minus 3. You're saying 9, God bless you. Plus 3 equals what? 12. Now the limit from the left is minus 3. The limit from the right is 12. Are they equal? No. So the limit of this function does not exist. Now, is the function defined? Because listen up, there are 3-step continuity test. Right now, you know the limit from does not exist at minus 3. Why? Because the limit from the left, limit as x approaches minus 3 from the left, is not equal to f of x. Is not equal to the limit as s approaches minus 3 from the right of f of x. Hence, the limit does not exist. Number 10. How do I know if the function is continuous? In the first place, there are 3-step continuity check. For a function to be continuous at a point, listen. I said for a function to be continuous at a point. In fact, let me say let f of x, please, you can write as I dictate. We say let f of x be a function and x be a point in its domain. You know the domain of a function is set of the input. The output is what? The range. Let f of x be a function and x be a point in this domain. Then we said a function is said to be continuous. F is said to be continuous at x equals a if, number 1, 3-step continuity check. It's just a 3-step. First step, the function f of a is divine. That is, when you do direct substitution, and then for that point, you get a definite value. Infinity does not make a function divine here. Please note, if by direct substitution you get infinity, it is not divine at that point. My brother, think of something else. Life is that easy. So think of something else. It's not divine at that point. So we say for f of a is divine. Now somebody is thinking, I'm coming, let me give you all the condition, then we now go back. The second part, the limit as s approaches a of f of x exists. Limit as x approaches a of f of x exists. And we've told you that the condition for limit to exist is what? Limit from the right matches the limit from the left. So now the third thing, the third condition is what? F of a equals the limit as s approaches a of f of x. That is, the result obtained here will be equal to the result obtained in step 2. If the result obtained in step 1 equals the result obtained in step 2, then we'll say yes, the function is continuous. Now listen, if it fails at any point, the function is not continuous. Now, I repeat, if it fails at any point, the function is not continuous. Now, for this thing, I will show you, well, maybe we make a series again on continuity of function. Graph-wise, we used to say a function is said to be continuous if the graph does not stop. You just keep drawing. Once you place your hand on it, you keep drawing. And then you don't need to remove your hand at any point. Any point you remove your hand and you have to jump to a point, or you have to make an O, definitely there's an issue there. If you're plotting the graph of a continuous function, it should just be going like that. If it is a curve, you just start and then you keep going. Some of you can bear me witness if you're drawing a quadratic curve. Just to give you a general quadratic function, a general linear function. Quadratic I mean x squared plus 4. Linear I mean 2x plus 1. You don't need to remove your hand. You just keep drawing. And then you can draw it. Only that they limit it. And then you start from the point where they limited it. And then you bring it down, make a U shape, or you make an inverted U shape. That's because it is a continuous graph. Are you here? So now, if a graph is discontinuous, at the point of discontinuity, is either there will be a jump or there will be an O. Now, if the function is divine, f of a is divine, and the limit does not exist, the kind of discontinuity that we'll call here is what we call jump discontinuity. Jump discontinuity. I repeat, jump discontinuity. Now, what if the limit exists? The function is either divine at that point or not divine. Now, if the function is divine at that point and it's not equal to this, that is, this one is divine but not equal to this, or it's not divine at all. If it is undivine, it will not be equal to these two. So if that is divine at that point or not divine at that point, now definitely, but the step 2 is the step 2 old. Limits exist, but they are not equal anyway, either because this one is not divine or because there's an issue. The kind of continuity that happen here is what we call it removable discontinuity. There'll be O at that point. And because there is an O, you just have to you can remove it. What do I mean by removable discontinuity? We said the answer we get for the limit for f of a. We said the answer we get for the limit for f of a, making us correct that issue. So thereby closing the O. Naturally, there will be an O discontinuity, and for you to correct it, that is the only way. But for jump discontinuity, you cannot correct it. It is a jump because the limit does not exist, and there's no way you can correct that. Like the limit from the left is not equal to the limit from the right. Now, let's analyze this based on what we've said. This is a piecewise function with the definition we gave earlier. The definition of this function is f of x equals what? Now, by the region, this is the f of x is what? 2x plus 3, where x is less than. Note this circle we don't close it. It is an open circle here. I'm saying the open circle here. You see that at that point, there's an open circle, meaning that it is x less than minus 3. If it is less than or equal to, it will be shaded, like in the case of this. Like in the case of that one. So that's how to know regions. Please note, graph. In case someone tells you to plot the graph of a continuous function, of a piecewise function, note that that's how it is. If there's a or equal to, then definitely you shade it. If there's no or equal to, definitely it is there that you only put a circle there. Now take a look at this now. It is of this definition, this part is for what? The part from, check it, this is where x equal to minus 3, yes. And then y is what? X equal to minus 3. And then downward, minus 3, minus 4, minus 5, minus 6. So that is what? F of x equal to 2x plus 3, where x equal to minus 3. And then don't forget, the second part is from here to this point. Sorry, here. That is from what? Minus 3 less than or equal to x, because it is shaded. That's why we say less than or equal to. And then x less than 2. So the region for this other one, for x squared, the domain of x squared plus 3 is minus 3 less than or equal to s less than or equal to 2. And the domain for 7 is what? X, don't forget again. Sorry. At that end, this one, the shading here, the shading at this point is a blue shading. So because it is a blue shading now, meaning that for x squared, the domain of x squared plus 3 is actually minus 3 less than or equal to x less than 2, because it is not a green shade. The green shade means it is that 2 is a point in is still part of the domain of x squared plus 3. But because it is not shaded in green, then definitely 2 for x squared plus 3, 2 has nothing to do with that. And then for the other one, for 7, obviously this is what? S greater than or equal to 2. That's a piecewise function. Now we're seeing something. We said if the limit, now look at me here, this is about the graph. You can see it here. We told you that if the limit of a function exists, the graph will continue from there. There will not be reason to stop. That is, now, at this point here, at this boundary point, the limit exists. The limit exists here. In fact, it is continuous at this point, at this boundary point. And you can actually examine it. We examine it. Now, if you test, don't forget, the function they gave us is x squared plus 3. The boundary point here is 2. If you put 2, 2 square is what? 2 square is 4. 4 plus 3 is 7. That's limit from the left. And then examining the limit from the right, they said f of 4 s greater than or equal to 2. So from the right, you are using the part of greater than or equal to 2. They say it is 7. So 7 from the left, 7 from the right. It is what? The limit exists. And in fact, f of 2 is equally 7. How do I know f of 2 is 7? Because the third part of this definition, it is what? Greater than or equal to. Greater than or equal to, that is f of s greater than or equal to 2. So if somebody tell me what is f of 2, I'll use, because there's an or equal to associated to the domain of 7. I get what I'm saying? So I'll use the or equal to part. So f of 2 is actually 7. So that is, the limit exists and it is equal to 7. F of 2 is defined and it is equal to 7. Then the function will be continuous at that point. Meaning I will draw the graph without removing my hand. And that was what happened here. We drew the graph without removing our hand. That was exactly what happened there. We drew the graph here without removing our hand. There's no need for jump. There's no need for O. Do you understand now? That is how we know a continuous function. Do you get what I'm saying? 3-step continuity function O there. Now, but for this one, there's an issue. And it is not correctable because the limit here, the limit at x equal to minus 3 does not exist. How will I do that? This is the part from the left. This is the function from the left. This is the function for the right. I mean, taking minus 3 as a reference point. Using this function, and we get 2 into brackets, minus 3 plus 3. We did that before. What do we get? We get minus what? God bless you. What are you saying? We got minus 3 for this part, limit from the left. And then for the right, we did minus 3 squared plus 3. Minus 3 all squared, that is 9. 9 plus 3 is 12. So the limit does not exist. Are you get what I'm saying now? So the limit from the left is minus 3. The limit from the right is what? Is obviously 12. So the limit does not exist. So there will be a jump discontinuity. This is a discontinuity because the graph, we cannot continue it from here. So we actually stopped it here and then we have to continue it here. That's why we call it what? A jump discontinuity. Now, someone is asking, does it mean that f of minus 3 is not defined? Let's check it out. For f of minus 3, the part of the definition we are going to use for f of minus 3 is when they gave us or equal to. Now, you know, for this linear part, the domain is x less than 3. So we are not using that part for f of minus 3. I get what I'm saying? The domain is what? X less than minus 3, sorry. X less than minus 3. That is the domain of this. Now, but the domain of x squared plus 3, we say is what? Minus 3 less than or equal to. Or equal to. Or equal to. Because there's an or equal to there now. If somebody asks you what is f of minus 3, you're using the x squared plus 3 part. In fact, someone is saying so that is f of minus 3 is actually equal to the right hand limit. Yes, but the left hand limit does not agree with the right hand limit. Hence, at that point, there's nothing we can do. Do you understand? So we have this function, it has 2 boundary points. Point minus 3 and point 2. At point minus 3, the limit does not exist. Hence, there's a jump discontinuity there. And then it cannot be continuous. Since the limit does not exist, it cannot be continuous. There's a jump discontinuity. At 2, the limit exists, and in fact, it is equal to f of 2. Hence, it is a continuous function at that point. So the fact that we give you a piecewise function does not necessarily mean that each time they give you a piecewise function, then you zero your mind. It can never, the limit, in fact, it can never be continuous. No, there are piecewise functions that are continuous at boundary points, and there are piecewise functions that are not continuous at boundary points. Most of the time, for piecewise function, if they are not continuous at the boundary point, note, most of the times it's always a jump discontinuity. Note what I'm saying, please. I said for most of these are piecewise function. And you notice that they are not continuous at the boundary point. It's most at times like 80% or more than that used to be jump discontinuity. Why? Because the limit from the left will not agree to the limit from the right at that boundary point. I want to believe this gives you a big understanding of the concept you're talking about. Thank you. Again, if you've not subscribed, brother, you don't want to miss these lectures. There are a lot of things we have in mind for you. Either you are in university, you're a teacher in a school, you just want to understand maths well. This has nothing to do with anything. Or you're just there, a parent who want to understand maths, you're just there, a student, either you're in secondary school, you can know all of this. There's concept of limiting your books. So, and regardless of your class, regardless of your age, regardless of wherever you are, whoever you are, please, you can subscribe to the channel and turn on the notification bell, please. You need to do that so that each time we drop educative videos like this, it will pop up as a notification, and then you can always see it for yourself.